Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Alright, hey everybody. Hope you've all had a great couple days. Yeah, I have too. I'm a little bit crunched for time on one project, so I guess slightly stressful, but that's alright. I think I'll be fine. But okay, so today we're going to work on some more on the what I guess a URP shader, only in HLS cell code. So yeah, no shader graph. Mostly because I'm working on a tutorial for it, so I thought we could practice it on stream. And last time we are pretty much done with the base shader, except now I need to add a meta pass so that we can support the light mapper. So I think that's what we'll start with today, and then after that I'll have a variation that uses custom lighting, and I guess we'll go from there. All right, I forgot to open up Visual Studio. Okay, there we go. Okay, so let's close this. So we'd already kind of started on it. I have just the meta pass code commented out. So we'll uncomment it. And again, the meta pass only runs during the light mapper, and it pretty much tells the light mapper some information about the surface. So we'll output like the color of the surface, and then like any emission. Okay, don't need to worry about that right now. Okay, so do I have... Yeah, so my lit meta pass, but we haven't actually done anything yet. So I'm mostly going to be able to use the URP lit meta pass as a base. So you can see in the vertex, they call this meta version position, and we want to be able to use this because, well, when you're outputting to the meta pass, you're basically outputting data to some temporary texture. So we need to allow URP to configure that because we really have no idea. And then in the fragment stage, it basically just fills this meta input value, and then we also call this meta fragment. So I think we can get that information using this, or those functions, from this meta input file. So we'll go ahead and include that. And then we can see that in the attribute structure, it has the position and the normal. It never uses the tangent, so I'm not sure why that's in there. Because, right, it actually, it never even uses the normal, so I don't know why that's in there either. But yeah, because it only uses the position and then the various UVs. Anyway, so structure, attributes, we'll have the float 3 position and object space, and then we'll have a float 2 UV, and then we'll have the static light map UV. It's in text chord 1, and then there's a dynamic light map UV that isn't actually used in until 2020.2, but I'll go ahead and include it here because we can see here that it still likes to have it passed. All right, and then in the interpolator structure, we need, do we only need the Yeah, so we just need the clip space position and then the UV because we have to read from the color texture. So UV text chord 0 and then float 4 position clip space is SV position. Okay, and we'll go ahead and include. All right, well, we have the. All right, so I have this non-meta input, but can't it just go? Can't I also use it in the meta pass? Because I still need to use the textures and everything. Oh, okay, but there's no. I think the reason I thought maybe not is because there's no instancing in the meta pass, so I don't need to do this C buffer thing, but I don't know if it really matters. Let's see. Let's look at the meta input class and see how they do it. Okay, so yeah, it has its own meta pass buffer. Okay, so let's see. So I guess it is slightly different. I wonder. It'd be nice if I. Well, I guess see some of the stuff we might not need in the meta pass. Okay. Yeah, I guess there's no alpha cutout. Okay, and then it was, yeah. Buffer. Okay, we don't do any normal mapping, so yeah, we don't need the normal map, I guess. We don't need the ambient occlusion. Okay, so I think this is fine. Oh, wait. Okay, I'm writing in the wrong file. Okay. Okay. So now we'll have, gosh. Interpolators. Vertex. So this will be our vertex function, and basically we'll just call that unity lit vertex function from here. So it's the meta vertex position. And it needed the object space position, and then the light map UVs, and then these light map scaling factors. Okay, and then for the UV, you can basically just pass that through, except we need to call this transform text macro to apply scaling. Now, what about usually when you have to use a value inside a constant buffer, you need to initialize the constant buffer by calling that macro. I don't see that in here. Okay, so I guess, yeah, maybe you don't have to do that, so that's nice to see. All right. And then in the fragment function, we'll return a color. Okay, so for this, basically it grabs a lot of information about the surface and then outputs some color, specular color, and emission. So we can do the same because we have this the common file. Oh, where is it? That I have this function, so yeah, we just need to pass various information. Okay. So surface data equals create surface input. I'm just gonna copy this whole thing so I can remember the entire like argument order. So we're not doing anything with a normal map. So the tangent space normal will just point upwards. Again, we don't need any occlusion, so this will just be 1. Okay, so we do need to get the other ones. Color sample equals sample texture 2D. Color map, sampler, color map, and then the UV. Okay, and then the same thing for emission and the metallic and smoothness maps. Okay, now did I do anything special depending on if it was a specular or metallic workflow? Let me look. Okay, no, I guess that's taken care of just entirely in the fragment PBR function, so. Okay, and then I also, I need to include this file that has that function. So my lit helpers file. Oh, again, I'm editing the URP file by accident. Okay, so now I just need to fill out this data structure, the meta input, so it has albedo, specular color, and emission. And I guess we're gonna actually do this the same way, so I guess I can actually copy quite a bit of that. Okay. Oh, except wait, I'm not using this BRDF data, so maybe how's that handled? I think, yeah, this normally happens inside the lighting function itself, but I guess we'll just grab it this way. Okay. Undeclared identifier color tint. Oh, okay, so we need to include this file below where we declare the color tint property, so it's a little awkward, but it'll work. Occlusion minimum, okay. Okay, so this thing is here. We don't actually care about the occlusion, so we don't really need to include this, but I don't know if it really makes any difference, especially since the light mapper doesn't really run. It's not like, I guess, frame rate critical or memory critical, so it'll be fine. But for... Oh, I forgot the semicolon. Oh yeah, and then I renamed these to make it a little bit more obvious what they actually are. Float 3 to float 4. Okay, so this is a float 3 apparently, but I thought it output the clip space position. Oh, okay. Well, apparently in the metapass position is a float 4. Okay. I'm gonna need to see what that fourth coordinate is, or component. Now what? Okay, this should be a float 2. All right, and this should be a float 3. Cannot find kernel. Oh, yeah. That was fun. I was going to include them all in the same file. Duplicate constant buffer. Okay, I was afraid that would happen. So what it's saying now is that this C buffer is already called, but then I'm trying to find it again here. Okay, so maybe let's just not have the C buffer. I don't know what that will do. Okay, well, it still works. Otherwise, I'd have to, I'd have to rewrite this entire all this code from meta input, which doesn't seem very good for making sure that the code stays up to date with Unity versions. Okay, so now it's saying implicit truncation of vector type. So what? Float 2. Did I make... Okay, so these are all float 3. Oh, this is... Oh, yeah, so this should be a float 2. All right, there we go. Okay, so let's make a point light. I guess I'll make both of these not have a cutout texture for now. Let's make them static so that they show up on the light mapper. I guess let's do the Unity one as well. Maybe add a little bit of emission. Okay, so let's just see what this looks like. All right, this probably will cause OBS to stutter for just a second, but I think, yeah, we gotta test this, so hopefully it won't be too bad. Usually when I do it on the GPU, it's not too noticeable in OBS. Oh, okay. Guess we got an error. Undeclared alpha cutout threshold. I don't even... Yeah, I don't call it here. Yeah, I wish I would tell you like what pass. Okay, well maybe it's just throwing that error because I'm including this mylit helpers.hlsl. Okay, I don't know why that didn't show up earlier, but okay, so let's try it again. Oh, I think it already finished. Okay, well, I don't really see anything. Let's turn up the emission. Yeah, this color should also be in HDR so it can go above 1, I think. Okay, so let's see if this will... Okay, well, I'm kind of expecting this light to appear on this plane down here. This isn't static for one. Let's also increase that quite a bit. Okay, so now we can see, yeah, the emission is coloring the plane a little bit under the Unity lit, but not under mine. That makes me think, yeah, you can definitely see it on the light map. Okay, so obviously there's something wrong with my meta pass. Now that I think about it, in the lit meta pass, how does it even... It doesn't seem like it even uses a tent unless it happens here. So what does meta input? So, standard lit surface data. Trying to see, because this meta input doesn't seem like it has this function. Oh, but I think, yeah, I think that they actually include another file in the actual path. So yeah, it also includes, oh wait, that's the wrong thing. It also just includes the lit input class. So, that's not what I wanted. Okay, which just has this per material stuff. Okay, so maybe, yeah, this meta input should just be included in everything. So pretty much this mylit helpers doesn't need to be, or let me see. This non-meta input can just basically be everything input, and then the mylit helpers I can include in here. Okay, let's go ahead and do that. Let's change this to just mylit common, and it will have this information. Okay, and then I'll get rid of this file. And then in all of the passes, I need to include the new mylit common file. Okay, delete all that. Okay, so let's try to build the light map again and see if our emission color shows up. Did it happen already? Okay. I don't think it's actually running. I think sometimes it can kind of tell that you haven't changed anything so it doesn't run. But we gotta have it recompile because it doesn't actually know that the shaders have changed. Okay, but still not working. Okay, so this is included. Okay, and so this file so I don't handle any of this stuff. Do I need to though? Okay, well, it's really the same. It's just saying if it's a specular setup, then okay, yeah. Then it just uses the RGB. Otherwise, it uses the metallic. Oh yeah, and this is like if there's no texture. So which I guess we could handle, but I don't know. Let's see. What was that keyword again? Okay, so if it's specular setup, then oh, I did the wrong thing. Oh, it's not else if it's else. Then if it's the metallic, it should be 0. I mean, I guess technically they could both be on, but I don't know. Maybe it causes some weird bugs if they are. Okay, so actually it sets the metallic to 1 when it's on specular setup, so... Anyway, I don't think that is our problem here. Well, that's not true. Oh, I had on capitals, which I guess I do kind of want on so I don't get metallic everywhere. Okay, so this is what I was looking for. I don't, maybe this is a problem. I don't have any of these keywords on. Oh, actually I do. Do I? I don't think I do alpha cutout. Okay, but I guess this does actually do an alpha cutout, doesn't it? Because I think this alpha function handles cutout, but it's kind of annoying because it's not in this file, it's in the surface input. Okay, so I guess I do need to do alpha clipping on the meta pass, which I guess makes sense. So what I would do is call test alpha clip. But I don't think that is really our problem either. So I set the emission here. So I'm not sure. Let's see, is there... I don't know if these will really help much. Okay, so this is the emissive, but for some reason it's not showing our shaders, even though they definitely have emission. Oh wait, I think yeah, let's see. Oh no, I was gonna say maybe I don't call this meta fragment, but I do. Well, let's take a look at this and maybe it will explain something that I've done wrong. Okay, so there's this bit that changes the emission, but it mostly just changes from linear to sRGB, so it doesn't like set it to 0 at any point. But I guess we... Okay, so I guess what happened is if this is not true, then it just wouldn't have any emission. So do I need to like set a keyword or something? Let's see. Let's... Is there... Okay, so this has this emission thing, but I think that's... Well, I wonder if it is... It does have something to do with that, but I think it's actually just saying that it has an emission map. Yeah, because it also shows up in the lit pass, and I think that's set by the inspector. But I guess we can try just defining it. No, that didn't have anything to do with it. It's these, yeah, they are marked as static. Okay, we can see on the light map they have information, like they appear on the light map, but okay, well, let's see if something will show up online because I'm a little stumped. Okay, Unity custom URP shader, emission light map. Unity needs the flag emission GI set to baked always to include emissive materials into light maps. And a custom shader may not have this flag. To get the emissive material into the light map, please follow these steps. Make sure light map UVs are included on the mesh. Checking option important GI from the lighting window. Okay, if your custom shaders, you cannot make the third point from the shader code. And you cannot get emissive light into light maps because of that. In this case, you have to use a script that solves the problem. That's really annoying. Okay, this is a shame. Okay, so what this does is finds all tags of the material. Emissive to baked. Well, okay. I guess if this is what I have to do, seems a shame, but also a little hacky. Okay, so how do I want to... I guess I should just test that this actually works. So I'm going to do it sort of hacky, and then, I don't know, try to make something a little better. So script, let's do emissive material enabler. I guess it'd be a tagger actually, but okay, so for now I'll just put a list of materials on here. Okay, okay, so what was it? So global illumination settings. Okay, I guess I should see what other flags are in there. But first let me copy this into my tool. Knowledge bank. Okay, so why does it... Oh, I see. So it gets the material out of the renderer. Okay. I mean, it's kind of the same as what I'm doing here. Okay, so what other options are in there? So real-time emissive. Oh, that's kind of interesting. But I guess we just want baked emissive. Okay, and then can I... Was there like a context menu? Tag materials. Okay, so this should... Oh, I see. So I've got to do... Do I have to do this? To a field that calls a function? Okay, I think this is more what I wanted. Is there an error? Can't add the component emissive material tagger because the script class cannot be found. That usually means that there's a name mismatch, but... Oh, there is one. Okay, so now if we add our material, let's zero that out. And if I right click, it should have my, no, it's not. Okay, yeah, right click on the component. Okay, so tag materials. There we go. And now we'll clear and bake the lighting again. Okay, now it worked. Okay. Oh, so good. Kind of annoying that you have to do that, but I guess it is what it is. You could make, I don't know, an asset pipeline that would make that easier to do than rather than having to use a mono behavior, but I don't know, it's not really the point. I guess, well, could we do it? Maybe we can do it in the inspector itself. Since we already have a custom inspector. Right, yeah, because we have the material here, so we can just set material. Okay, yeah. All right, so let's. Okay, I'm just gonna. Well, no, I guess I can't duplicate it. Let's make a new material. Just for a temporary one, just to test if using the inspector works, right? Okay, and I'll just add it to there and set the emission map. Let's just do cloud noise. Okay, now why is it showing up completely black with no lighting? That makes things easier. Why is it black? Set as opaque. Oh. Okay, so I guess it didn't run to update all the information at first until I actually changed a property. So how can I... So, because I kind of like this update surface type to run when the material changes. Okay. We'll need to handle that. Okay, so we're working on the metapass. Up, I guess, initialize inspector keywords when material is selected. I don't know. I'm not sure how to do that. But anyway, we'll find out. Okay, so anyway, let's set these to static because I mostly just want to see if the light map bakes into it because now I forget what I was even wanting to test. Okay, I don't need that anymore. Oh yeah, I wanted to test if we could set it from the editor. So yeah, this material has never been set into that game object we created, so we'll generate lighting. And then go to emissive. Oh, good, it does show up. So yeah, we can even see the white spots there. Okay, well, I'm glad to see that. So we can set the emissive property from the inspector. So I guess we can move this into the code that runs. So I want something that runs like the first time a material is selected. Also, I wonder if this flag stays or if it's gonna, let's see, if it's going to not be persistent between like sessions. So let's close Unity and restart it and see if it still will build. Or I guess not build, but it'll still make the emission on the light map. Okay, still running. Okay, so thank goodness the material flags are persistent between sessions. Okay, so let's see, is there a way to, I guess, Unity Material Inspector run when shader selected. When shader first selected. Assign new shader to material. This method is called when a new shader has been selected for a material. Okay, maybe that will help us. On material interactive preview, on material preview. Okay. I guess this. Okay, so I guess I have to find out if the new shader is our shader. It'd be kind of nice if it would just, I don't know why you do it like this instead of it just like saying this is the shader it used to be and we're switching to this new material. Okay, but whatever. So if shader name is mylit, actually I don't even know. Let's do a debug. Okay, so that did work. So if new shader dot name is Ned makes games mylit, then we want to call update surface type on the material. So this will initialize all this stuff, and also we'll set this here so it doesn't have to run every time. Okay, so I guess to try that, let's make another new material. set it to the square, and then change to my lit. Okay. I don't know why it starts off like this. Oh, I guess it's because the emission starts off as pure white. But anyway, okay. So let's see if it will... if that also still worked with the emissive flags. So it should be red. Okay. All right, so we've finished with that. Let's I guess I'll just put this back on there. Okay, so that wasn't too bad. Now let's go the other way around and make sure that they can receive baked lights. So I think I'll turn off the emission by just setting the color. Now that I think about it, the color for, like, the emission color should probably start as black. Just so that it doesn't start with emission. Oh, okay, I don't know why that suddenly showed up. Okay, so let's make, already have a couple point lights. Just make them both static. Or, yeah, actually I have to make them baked. And let's clear the baked data again. Okay, still show up. We can make sure they're baked by, if we turn off the lights, the lighting still shows up. Yeah, I guess you can see the raw light map here. Okay, so yeah, they receive baked lighting and then also can emit baked lighting. So I think finally we're done with that. So let's see here. We've fixed this, and yeah, I'm not going to worry about parallax or detail maps because basically my patrons don't really care about recreating the lit shader that much. They more are interested in custom lighting. So I don't know, maybe we'll have a separate tutorial on how to implement that kind of thing. All right, so yeah, I think we're done with the meta pass. Actually, I thought that it would be I thought it would be pretty quick, but we ran into a couple weird bugs, but that's okay. Okay, so next up we want to do a custom lighting shader. And I don't really want to make a whole separate shader for this. So I'm trying to think. I think I'll just stick with this, but then I'll have a keyword that we can toggle custom lighting on and off. And then, I don't know, you can have your own custom lighting script. Because most of this code will be the same for each of them. The custom lighting might not deal with metallicity, but usually they, well, I guess they could. But anyway, let's make my custom lighting file, and this will have the custom lighting algorithm. I kind of like to put it separate than any other file in the shader, so that way you could also include this in an entirely different shader if you wanted. Okay. I'm just trying to think about how I want to do this. So we could just use the surface data and the input data that we already have, but I feel like probably is better if we have our own special little structure, so that way we can add whatever we want to it. So custom lighting data. To be honest, I could pretty much just use the entire file from my shader graph custom lighting, which maybe that's a good idea so that I don't have to spend a ton of time figuring it out. So okay. All right, so let's see, what do we need? I guess I'll just put my at the beginning of it. So we don't need anything to do with the shader graph, so we can get rid of that little trick. Okay. And again, we're not dealing with shader graph, so we can get rid of that. Oh yeah, so in the shader graph we couldn't support screen space ambient occlusion, but we actually can now. Oh yeah, and then this whole thing is actually just for shader graph support, so we can get rid of that. Okay, so one thing I like to do, because we have the actual ambient occlusion, I think I'm going to add an ambient occlusion minimum separate value here, because I kind of like to also be able to like clip the ambient occlusion from screen space, so that way if you want to have, I don't know, like foliage, usually you don't want a ton of ambient occlusion on. So okay, so what else? Pretty much we already support most of this code. Okay, so let's now in the common file, we need another class here that will create that custom lighting structure. Or I guess so. Also, yeah, the custom lighting doesn't actually deal with emission, so I guess we should add that in. That's something else. I guess I'll keep the same order I had before. It also doesn't use like the specular or yeah. Well, I guess it uses the smoothness from it, but I don't know. I mean, I'm not trying to like recreate the entire lighting algorithm, because I mean at that point just use Unity's built-in thing, but I think you could probably extend this to do like a toon shader or whatever other effect you wanted. Okay, so let's go ahead and make a keyword here. So you can just do toggle custom. That's not how you spell custom. Okay, so probably what we'll do, so custom lighting. Well, okay, so the reason I'm thinking like, do I need to add it in here or not is because like in the meta pass, well, I guess we'd want to use trying to think. So I guess we'd want to have like a custom meta thing as well. So maybe that's what we would do here is in my custom lighting, we would include calculate like meta custom lighting or something. Oh, okay, so I can't include that there. Because I don't know, because I could just include the meta input here, but then it would be included in all passes that use it. And I don't think that would be a good idea. So I guess we can just have another file for it. But I mean, I don't know, maybe it's not super important. Because what would it even be? Basically, we would just be returning the albedo, and we just set specular to 1, and then the emission to the emission color. So I don't know. So let's see if custom, or did I put an underscore? Yeah. Okay, so I mean, if we're using the physically based rendering, then we do this. Otherwise, we can just set meta input dot albedo to the color sample. Yeah. And then in the forward lit pass, if it had custom lighting, then we basically would do this differently. So if custom lighting, or wait, isn't it? Yeah, custom lighting. Did I just make sure I spelled it like that? Okay, I did. And then else. Okay, let's set the color out here. So float 4. Okay, so this time we'll, I mean, it's pretty much similar here, but we would use the custom lighting data. Okay, so we got position, normal view, shadow chord, fog chord, vertex lighting, baked GI, shadow mask, and screen space, which I think is here. So position, normal view, shadow chord, screen space, baked GI, shadow mask. Okay, I think that's all the same. And then I also put the fog factor in here instead of calculating it outside. That way, if you wanted to do custom fog somehow. Okay, and then we also need the surface data. So lighting input dot albedo sample RGB times color tint RGB, and then input dot emission is emission sample GB times emission tint. Oops. Smoothness times, okay, let's do it the right way. Metallic smoothness specular map. The smoothness is in the alpha channel. And we don't care about specular color or metallicity. Okay. Occlusion sample. Oh yeah, and then we have the ambient occlusion minimum, which we'll just set to that property. Okay, I think that's it. Yeah, but I just remembered I don't actually use the emission here. So what I need to do is emission you just add to the end of the color. It's pretty simple. Okay, and then I just need to set color equals calculate custom lighting, and then I pass in the data structure. Okay. Oh, okay, so nothing happened. That's because I don't tell my shader to create a version of itself with and without that property. So what I need to do is such. I guess that's fine. Okay, unrecognized identifier, custom lighting data. Oh, that's because I don't use the custom lighting. Include, and I can even wrap this in defined. Because yeah, I mean, it doesn't really matter, but we don't have to include this if this keyword's off. Oh, okay, I guess I've forgotten. Oh, right. This indiff I can get rid of because that was due to the shader graph preview. Valid subscript. Fog chord. Oh. Okay. I think, yeah, I named it fog factor there, but I think I'll just to keep the names the same with built-in lighting. I'll just rename this to fog coordinates. So I guess that's one difference between my shader graph version, but normalized screen space UV. Oh yeah, and I just called this position normalized screen space. Really? Maybe I spelled the whole thing out. It'll be in here. Oh, I just called it occlusion, man. That's fine. Flip 3 to flip 4. Oh yeah, so this calculate custom lighting doesn't handle the alpha channel. Okay, that's actually, yeah, it'll make that pre-multiplied alpha mode not work, but like I said, I don't really care if the custom lighting implements everything, because then just use the default shader. I don't know why it keeps giving me this warning. It doesn't have anything to do with me. Okay, so yeah, this is with custom lighting on, and then we can turn it off. Okay, yeah, we can see it's a little different, of course. So yeah, with the custom lighting, you can implement pretty much any kind of effect you want. You could do a tune shader relatively easily, but I don't know if we probably won't implement that in this video or in this tutorial. Because I kind of like to do, I need to do a whole new video on a tune shader because there's a lot of other techniques with tune shaders that I'd like to check out, and I need to update my shader graph version anyway. Okay. A little bit of my hair sticking up. My hair's been so crazy today. Oh well. Okay. Let's see. So is there anything else I want to do to the custom lighting? Okay, so I handle screen space. We've got baked lighting. And we use all the same keywords that the normal lit shader does, so I don't have to worry about that. Yeah, we have... yeah, basically everything that's important. Got the main light and then additional lights. Vertex lighting, emission, and fog. Okay. So I don't know. Like I said, like you could edit this. Like if we didn't want ambient reflections, we could get rid of that pretty easily. see. I think the biggest difference between the custom lighting and then the default lighting is the way that reflections work. Like the custom lighting is a lot more stylized, but it's much simpler. And also, of course, custom lighting doesn't even try to do anything with metallicity. Okay, I guess we could make sure that it works with the screen space ambient occlusion. If we just move those close to each other. Oh, okay. So I already had it turned on, so yeah, it does work. If we turn it off, yeah. Okay, so that was easy to test. Okay, let's see what else is on my list to do. So that was pretty easy. Okay, so yeah, there's a lot of changes in 2021.2. So, and I'm pretty sure my custom lighting doesn't support all of them, so I guess we can try it out. I know the meta pass has also changed quite a bit. So some of the things I just implemented might not work quite as well. What's with the pixelation? Probably compression on the normal map. Let me see. Yeah, so if I does that make a difference? So I turn off. Yeah, so yeah, the compression, but I don't know. Don't really notice it when you zoom far in. Okay, so let's save the work I've done here and then switch to 2021.2 and see what it looks like. Okay, I actually haven't even created a repository here yet, so let's do that. And we'll grab a get ignore file real quick. Okay. All right, and then we'll switch to a new branch for 2021.2. And it's always good to do this because it's hard to, well, I don't know, maybe most people don't have this issue, but since I try to make tutorials for 2020.3 and 2021, I need to be able to switch between them pretty easily. And the Unity doesn't really like to backport a project, so the best way to do it is kind of keep a separate branch for each version and then switch between them as needed. So that's what we'll do here. So yeah, I'm in the right branch. Okay, this will probably take a minute to start up, but all right, so let me think of stuff I need to check. I think yeah, it already started. I need to update shader graph. Okay, so these are kind of things that we need to check on. Might not implement them all, but let's see what we can do. Okay, so we already know that works. Screen space shadows, decals, light layers, light cookies, custom. Okay, that's the shader graph only thing. But yeah, we've got reflection probe, blending, and then the dynamic global illumination. And then I guess, yeah, we just need to check the meta pass. Yeah, so as you can see, they added a lot in 2021.2. So yeah, it's definitely made it an interesting. It's definitely made it interesting to try to support it and also older versions. Okay, yeah, I guess that's not even new. Oops, why did I do that? This isn't even new in 0.2 for code shaders. It was just in a shader graph, because before 2021.2, shader graphs or unlit shader graphs wouldn't get a depth normal pass, so they wouldn't work with the screen space ambient occlusion. But now they made it so that I do have a depth normal pass, so that's always nice. I don't know, I think the screen space ambient occlusion really adds a lot to most scenes, so I was happy to see that I could use it in shader graphs now. But I don't know, I hope with this, of course writing a code shader is a lot more trouble than in a shader graph, but I hope with this tutorial that it'll at least be something people feel like they can do, because there still are things that you can't do in the shader graph, and I don't know, sometimes just writing a code is easier, so it helps to kind of have a shader that you can start on or start with and then expand from. So I don't know, maybe the shader can provide that. Okay, that's fine. I'm not going to worry about updating right now. Let's use my tutorial layout. Okay, yeah, so I know this problem I had to deal with on my tessellation tutorials, but they basically changed. Oh, that looks ugly. What's going on right there? I think it's just, it's like some weird, I don't even know if you could see that on stream, but there's like some weird speckling on it. But anyway, it's probably because the shader can't compile. But they changed the light map scale variable, so you have to use something different now in the meta pass specifically. Okay. So we can look at the new lit shader. And actually just included it in the shader library. Yeah, it has some more interesting stuff for like the editor visualization. Yeah, they've had a bunch of new things here. I'm trying to see. I haven't played around in 2021 or 2021.2 very much. So I was trying to see, where did they put, okay, this is what I was looking for. Okay, we can see there's no light maps built yet. Oh, actually there are, but it doesn't show emission. But I think it might still be because there's this bug or error. Let's pin this so we don't have to seek over to the edge of the screen every time. Okay, so we can see it still calls this meta vertex position, but it's different now. It doesn't include the scale variables. It only includes the UVs. So I guess I want this to support both versions. So I'm going to have to do an if statement. And if I remember right, let me see, there's a way that you can check. I think it's in the core shader library. There's a version file and it defines a keyword you can use. Okay, the old version number system below is deprecated with graphics packages, so you just should rely on the Unity version now to detect example. Okay, so yeah, they don't want you to use these anymore. Okay, so we can just use this. That's exactly what we wanted. Okay, so if the Unity version is greater than 2021.2, then we'll do something different. But otherwise, we can use this old system. Okay. Output dot position clip space equals. Okay, so now it's Unity meta vertex position, so it's a little different. Okay, so we'll use. Does it still? Yeah, for some reason there's the position object space is still a float 4. I don't know what's in that fourth component. They don't even use it anymore, but. And then, yeah, the static light map and the dynamic light map. And then I guess this editor visualization. Let's try it. I don't know what it does. Okay, well, let's not do it and see if we're like missing anything. What else is there? Okay, so I'm trying to remember. There's still a bug, and there was something else I had to change. Because it still says something about the light map is not declared, even though I just got rid of that. Yeah, and of course, the annoying thing is that the line numbers doesn't help much. It says 81, but there's not an 81 here, and there's definitely... This isn't the line that's causing the bug. Let me look. In my tessellation tutorial to see if I can remember. It was a weird bug, and the error like doesn't give you any information really. Okay. Oh yeah, so the specular color didn't appear either, but oh right, so yeah, the meta input doesn't include this core I guess hash include anymore, which is kind of weird. So you just have to include it yourself, and it doesn't really cause any bugs in the old version. But let me see. Let me just write a note here. So must include in 2021.2. So I remember. Okay, so now it's saying invalid subscript specular color just because this doesn't exist in the new or in Unity 2020.2. Let's increment that. Okay, there we go. It wasn't letting me move. Okay, so let's see. Okay, so none of these are working, really. Let's just pick a new light map. It's still working. Okay, actually, yeah, it still has that like dithering effect. Does that appear? Yeah, it even appears in game. I think it might have something to do with shadows. I thought that might go away, but so the albedo doesn't show up. Okay, well, there's no emission, so that's fine. I guess I should test it again here. Let's just try it one more time. Okay, I just want to make sure that the mission still worked. Okay, well, I'm not sure what I'm missing with the by not including that visualization stuff, because it seems like everything here is the same for both files. Like there's nothing that one like the default one includes that the other ones don't. Maybe is there something else? I know they did a lot with like the frame debugger in this version. Maybe that's where it is. Oh, they have this rendering debugger. Okay, so this is different. Oh, this is really useful actually. Because I would test this kind of thing all the time, but you can't do it. Now, how would we get this to work with custom lighting? I'd really like to do that. Hopefully there's an easy way. Oh, that's super useful. Okay. Oh, you can even see the depth texture. cool, it shows overdraw. Okay, yeah, I love this. We've got a, I really want to support this now. Okay, so let's see, that must be what this editor visualization stuff is. Let me see here. While I'm here, is there anything different about the lit pass? Oh, this is my shader. Where's the default lit shader? I just want to make sure there's not like some more keywords I need to work with. Okay, so editor visualization. And where is that handled, I wonder? I'll have to look and see if it appears. Or does it show up here? Editor, clustered rendering. Okay, so light cookie, light layers. Okay, this is for, I guess, deferred buffers. I don't know if I guess we could support deferred rendering. That's kind of a whole nother not box of worms, because it's not bad, but it just makes things more complicated. And you can't really do custom lighting with deferred rendering, so I don't know. But I'll write it. But I really like these editor visualizations. Okay, and then this debug display as well. Okay, so it's actually, yeah, like I said, they added a ton of new stuff. Okay, so we don't, yeah, this is the deferred render pass, which we don't even support right now, so maybe we can add it. Okay, so here, maybe I should figure out how the editor visualization works for the lit. Well, okay, well, if I can get it working with the meta pass, that's probably simpler. But yeah, what I was looking for, they kind of have, Unity has these grouped together, like these are set on the material either by the inspector or from properties. And then these are like set by Unity automatically, so you don't really have to worry about setting them yourself. So the debug display is right there, but I don't see. So the editor visualization must just be only for the meta pass. So, and then the debug display is handled by Unity. So, okay, that's good to know. Also, one other thing I noted, yeah, I don't need to include these exclude renderers. Just from, I thought that Unity didn't even support those renderers for URP, which was kind of strange thinking back. But it was just from me kind of hurriedly reading these shaders and seeing this line, but it's because they have a duplicate pass for only these renderers, but I don't really need to support that. That's like an optimization step. Okay, also, I guess before I do anything else, I should figure out what's going on with the speckled shadows. So if I turn off, what's going on there? Okay, so even with custom lighting, they're like still kind of ugly. I want to turn off the lighting gizmos. Okay, there we go. Doesn't do anything. I guess I should turn this on to make sure everything works. Oh yeah, what's with that? Okay, there's definitely something weird with shadows. And then you can see there's this line right here. So I must calculate the shadow coordinate wrong. I don't have... Well, I just have screen space ambient occlusion. Oh, it was the SSAO. Okay, yeah, shadows are still working fine, actually. Yeah, I guess I should test shadows a little bit more just to make sure. So we'll leave that one up above. Okay. All right, well, let's see about that. Okay, so I guess I will add this back in. Okay, so if I turn this on, it makes them look weird. So I guess the first thing is, let's check that frame debugger is showing the correct depth normals. Okay, yeah, it's kind of hard to tell because they're like encoded in a weird way, and they're also in view space, but I think this is right. Even though like it seems like the green are at different positions, it's just because this is how it works. I guess if I move this over, they should have nearly the same. Okay, actually they look reversed, don't they? Okay, so let's see, maybe that has something to do with it. Let's check. I guess Unity might have changed the way that they encode the normals, so we'll check in the depth normal pass. Okay, it's quite a bit more complicated now. Okay, and they actually include normal maps in the depth normal pass, which they used to not. Normalize. Okay, so they don't pack it all the time. Do they just return the normal in world space? Hmm. Okay, let's close all this. I'm gonna need to... This means that like the global buffer normals, I think it's oct encoded, but usually this is just for what's it called, deferred rendering. Let's see, so gbuffer pass. I'm just going to check and see how this works. Yeah, so the gbuffer pass, the fragment output actually outputs multiple things. Like, of course, it's not defined here, so it's in the Unity gbuffer class. So let's check that out. There's a lot. Okay, so okay, so it's not really helping me too much. I don't know. I don't really want to get into the deferred render at the moment. But anyway, so I was mostly checking to see, does it output normals as well? Usually, I would think they do. I guess I still need the normal for the lighting. Oh, but see, the thing is, you don't calculate lighting. So the thing is, the deferred renderer, there's like multiple outputs for the fragment function, and it writes to a bunch of different textures. And usually there's an albedo texture and then a normal texture. And the advantage of doing that is that you basically can calculate all lighting in a post-processing pass. And so you can kind of like cut down on the number of lighting calculations you have to do because lights only affect a certain part of the screen. So that's the idea behind it. So you wouldn't calculate lighting here, you would do it in a post-processing pass, but I'm just trying to see. Okay, so it does do baked lighting though already. Okay, I don't know. Some of the stuff might be getting to the point where outside the scope of the tutorial just because I have to stop somewhere, but I don't know. Screen space ambient occlusion I do want to do, so let's get back to that. Okay, so this is there. Depth normal pass, so I just need to make mine match that. Okay, so I used to use this function, but it seems like they do it differently now. So packed normal oct quad encode. Used to I did oct rect encode. I don't know if that's much different. I also don't normalize it, which is probably a mistake. Unless this transform world to view deer does. Which I think, yeah, I think that's what the true does. It normalizes it. Okay, and I need to remember if I make any changes, I need to wrap it in that version thing so that it works for both. I wish that this was in a nice function so that I could, well, I guess we're not using parallax and everything. Okay, well, this begs the question, do I want to include the normal mapping in this? Because before this, like in older versions, I didn't include the normal map in the depth normal texture. But now they are. Well, I guess let's just check and make sure that it works okay if I just output the normal. Okay, so if version greater than or equal 2021.2, then we'll do something different. We just output the world space normal. So we would return float for normalize input normal. Okay. Unterminated conditional expression. Oh, I did two else's. It's trying to drag this over, but it's, there we go. Is it? Okay, just making sure there was no more bugs, but they still don't match. This also isn't the world space normal though. Well, maybe it is. If I Move the camera around. Because if it was the world space normal, you would expect. Oh, come on. You'd expect blue. Okay, so there it is. There is blue on it. So they definitely don't match. Okay, and you can definitely tell that there's a normal map in here now. Maybe this is the wrong number there. Oh, it's Unity version, not just version. Okay, so that was the problem. So if I put this in, okay, so now the colors match. So it is in world space. Okay, so I'm trying to decide. Do I want to apply the normal map here for everything, even though in previous versions they didn't match? I mean, in previous versions, it didn't include the normal map in the depth normal pass. I mean, I guess I can just make a note of it and people can decide what they'd rather do. It's not like it's super difficult to include. I could just copy this code here. In fact, if I'm gonna do it, I think I might make a helper function. So let's common so float 3. Let's do calculate normal. So float 3 normal world space tangent and normal tangent space. Or okay, let's just do a normal map sample. Okay. And yeah, instead of sampling it, we'll do that. And I guess we could sample it because we have all this up here, but I haven't been sampling the textures before, so we'll leave it. Okay, and this is normalizing it at the end, so we don't have to normalize it before. Okay, and then in the forward lit pass, we would just say equals calculate normal input. And then this texture sample. Okay, yeah, we don't need this here, but I should keep it in here. And unpack normal scale is and shader lib packing. Okay, so then pass this to the depth normals pass. And yeah, so now whether it needs to be encoded or not, we can just do that. Okay, so now I've got to pass the tangent vector through here. Not that's difficult. Oh yeah, one other thing I just remembered here, the tangent is actually a float 4 because it includes the bitangent sign. Okay, and then we'll also need the tangent vector here. Update the coordinates. We just need to pass through the bitangent sign because that's not included in this variable. Okay. Oh. Got a bug. Undeclared input. Oh, right here. So we just do that. Okay, still something wrong. Calculate normal cannot implicitly. Okay. Move this out of the way so I can see what's going on. Calculate normal cannot implicitly convert from float 4 or float 3 to float 4. Oh. Okay, so I guess now we always need the UV. Yeah, because before we only needed the UV if we were doing an alpha cutout. Okay. Well, that makes this a little easier. Great, surface input. Oh, so now the tangent space normal, we don't have it at this point. I still don't know why it needs a tangent space normal, but... Okay, how do I... Has to throw a wrench in everything because I like the simplicity of this function, but if we need the tangent space normal, then I'm gonna have to have another like out function here. Oh, I guess if we have to. Thanks for the follow. How do I want to do this? Maybe I just need to make a separate function for calculate tangent space. Makes me miss Lua return values because then you could return 2 or multiple values, but only use 1 if you needed. I don't like whenever I have an out parameter. I don't really like returning one because it's just confusing. Okay, well, if we have to do it this way. I mean, I guess the other, I don't know, we could do it that way. We could also do it like this. Unpack normal tangent space, and then we would just do, I don't know what's really easier. I guess this is slightly better. So there we don't need that, and we can just so then here we would just call unpack normal tangent space. Okay, actually that's starting to be a bit too long. Okay, I guess I'll just copy this into the forward lit path. Okay, so now it has access to both for whatever reason. I still don't really know why. I guess I should go search through the code, but I haven't been able to find where the tangent space normal is ever used in the surface input, but it does ask for it. Oh. Okay, so now they're basically the same. Okay, every time I change something, the scene windows stop responding. Let's just move this down, get it back under shadow. Okay, I guess I can. Well, okay, let's make sure, since we had that one thing, let's make sure that the depth path still works. So if I change, oh, also, okay, that did fix the weird speckling. So it was just because the normals used to calculate the screen space ambient occlusion were in view space instead of world space. So I'm glad that's fixed. So we use depth. Okay, well that's not my problem. Okay, good. So the depth looks the same. So that's still working. I guess let's just take a quick look at the depth pre-pass to make sure there's not anything weird. Okay, oh yeah, I'm gonna write a thing. So the lit shader does not use normal maps in the depth. Normals pass before 2021.2. Just keep a note for that. Okay, so we want the depth only pass. Okay, so it still just does alpha cutouts and then returns 0, so we're good there. The frame debugger certainly doesn't like you to change shaders while it's on, it seems like. Okay, so now let's put it back on depth normal. And I want to make sure that Oh, that looks ugly. Let's just... set them close to each other and then move one out. Okay, so this green space ambient occlusion does still work. Just want to make sure. It doesn't work here because... oh, it does kind of work, but this thing has a ton of emission, which kind of overwrites the shadow. Okay, so that's done. I kind of want to do the editor visualization because I just think that's really cool. So let's look and see if we can see how it's done in the lit forward pass. Okay, yeah, there's a dynamic light maps, which we'll get to. Okay, so it seems like shadows calculated quite differently. Let me make a note. And check on shadow chord calculation. Okay, so debug display. It's hard to figure out what's going on here. Okay, so if dynamic light map is on, then we set input data. But isn't this already set? Okay, so they must have added, I guess they added this to the input data structure just for the debug display. But how come I'm not getting an error then? Because we don't like set it to 0. Or do I? No. So there's like a bunch of fields that aren't initialized, but it doesn't seem to care. Maybe it sets them to 0 automatically. Let's look. So URP shader library input. Hopefully that's still there. No, the input field is gone. Our input file is gone. Okay, so where is it now? Before 2021.2. Oh, well, this is the core shared library. Yeah. Okay, so it's still good. It's still there. Okay, so the reason it's not throwing an error is because these things are always only included if this debug display is turned on. However, I don't set the tangent to world matrix. I do set everything else though. I thought it needed the tangent space. Or that's the surface data. So, okay. That's going to throw a wrench in what I just did because now it basically just needs everything. So why even have those helper functions? Let's see here. I don't know. How can I tell? I mean, does anything use it? Because my code is working fine without it. And it's really difficult to search through to find out because I'd have to search the entire solution for this, but it's gonna be like in so many files. Okay, well let's go go spelunking through the URP source code. Okay, so if normal map is turned on, then it saves it. But yeah, so I mean that's where it's set, but where it's actually used. Okay, here. So if normal map. Oh, well, no, it just sets it and then uses it right away, so there's no reason for it to be there. What's this? Okay, so it's a debugging thing. But why? I don't know why it does it like this because... Oh, okay. Actually, yeah, I do know. So the reason that they do it like this is because they want the version of the normal that hasn't been perturbed by the tangent matrix or the normal map. Okay, so it's only really used in debugging, but they, well, anyway, it might be used somewhere else too, I guess. I guess I could actually find this easier by doing dot tangent to world, so maybe that won't give it to us. Okay. This is where it just was. Yeah. Particles, but it was just set. Particles. I don't know why it shows it to me twice. More particles. Again, they just set it and then use it. So I guess, is it only for debugging? But then why even store it? Okay. So yeah, it's only used for debugging. I guess I'm glad to know that. Let's just close everything. But again, why? I guess I just don't know why it doesn't complain because I don't store it here. Okay. Well, all right. So now, I mean, if we need the tangent space normal, this tangent to world, and then the world space normal, I don't know if there's a point to put all them in this file. Maybe I should just have one function that outputs all of them. Or, I don't know, is there maybe no reason to do that? I don't know, probably useful. Okay, so we'll kind of go back to how it was before. And then we'll have out. Final, normal. And then the float 3x3, tangent to world. Just get rid of that. And then this is also in space transforms. Okay, so now we need float 3, normal world space, normal tangent space, and then float 3x3 tangent to world. And then we have apply normal map. Okay, and I guess I'll just copy this into the depth normals pass, because even though it doesn't really need that stuff. And by the way, this will still work in older versions, which is why I'm not doing the else if thing. But here I need to do if Unity version is greater than or equal to 2021.2. Then we put the new stuff. So lighting input dot tangent to world equals world. Okay, so what else is new? Okay, so I did that. I need to come back to the shadow chord, but we'll deal with that later. So if debug display, then I have to include this stuff. I don't even know. I don't even calculate these values. Let's see. Trying to see if it sets anything else, because it doesn't do like the textile size and all that. Oh, this is the vertex function. Set up debug texture data. Okay, so that's nice. I guess I don't have to handle all that myself. Let's see if this will work. My lit forward pass. Okay, thank you. I don't have to do all that. So the only other thing I have to do is the light map UVs and the spherical harmonics, which I should be able to do. So I guess I'll just copy this little bit of code. Okay, so if debug display and then that. Okay, so I don't actually pass this down. How do they handle that? So varyings. Oh, well, you do paths on the light map. Okay, I just don't do dynamic light maps yet. So I guess I'll just comment this part out for now. Well, it's going to throw an error, so let's set it to 0. Okay, so now I just need to set this debug display as a shader feature. And we should be able to see some of this stuff. Let's look. Lit shader. Okay, and do they put it? No, it's only in the lit paths. So I guess I should make sure. Oh, that's a G buffer. I don't care about that one. Okay. Yeah, and then the meta pass has this editor visualization, which I'll look at in a second. Okay, so again, this should only be included in the right version. Following conditional expression. Oh. Okay, of course it has to think a bit. Oh, this isn't what I want. I want the rendering debugger. Okay, so let's see if it's no undeclared identifier color map texel size. Okay, well, we can add that. I guess. I mean, it's kind of unneeded, but I mean, it's just a float 4, so again, we only need this if. Okay, normally it's not. You're not supposed to do if inside a command buffer, or not command buffer, constant buffer, because it will cause instancing not to work. But this case, I mean, it's based on the Unity version and not like something that could actually change per shader, so it's fine. Color map MIP info. I guess is that something else that's also a hidden value that's set? I'm not sure. I've never used that one. Look at identifier input data. Oh right, I call it lighting input. Oh come on, I wish it would automatically indent with these. Output parameter input data not completely initialized. Okay, you're not going to tell me what's not initialized, are you? Okay, so I set this here. Is this universal fragment PBR? Does it modify it? Oh, well, I guess I call universal fragment PBR, so. Okay, so if. Okay, so if it's debug display, then it does all this stuff. So, the input data not completely. Is that? Okay, yeah, that is that. I was gonna say maybe it's the surface data has something new that I don't know about. What's with all the ellipses in the comments? Okay, this is quite different. What use clustered lighting? Oh, this is light layers. Okay, I need to look into that. Light loop begin. Yeah, they changed this a lot. Gonna be interesting to update custom lighting in the shader graph to deal with this. They also changed the way they handled ambient occlusion. Okay, so anyway, so can override output color. Feel like if the bug display is on, it just calls this, and that's it. Okay, so this is it. So okay. Okay, so this is the only thing that's in the outside, but I'm not sure what did I not set. Okay, so I don't set this stuff myself, but neither does the forward pass. Unless it's set somewhere that's hidden. Huh. I hate to leave. I'm starting to run out of time, but I don't really want to leave with this weird bug. And of course, it doesn't actually tell me the line. Okay, so shader library debugging 3D 18. Maybe that'll tell us like what's not initialized. Okay, no, that's not helping me too much. Set up debug data texture. Okay, so this is the... Okay, this is funny. So it's saying it wants this stuff to be initialized and then... Okay, so I think the reason is because it's an in-out. So basically I need to initialize it to 0 and then it'll fill in actual values there. Okay, I mean, I don't really like doing that because it'll make me lose, like if there's some value that I need to set manually. Now I won't get an error about it, but I guess if we have to, we have to. Okay, so let's see. That did not do it. Really? Because now everything should be initialized no matter what. Need to... Okay, well no, this is calculated somewhere else, I think. Let's just check. Is it in lighting? Okay, where's this set? Because maybe I need to do it. No, I don't know where that's set, so... Oh, wait. Oh, no, I do. I was going to say, I don't even include the debug information, but I actually do because it's included in the lighting file, so we're good. But... just... What is it? It's still on 18. Is that... I wonder if that... No, it's still there. Setup data, debug data texture, output parameter, input data is not completely initialized. But that doesn't make sense because I initialize it myself to 0 right here. Okay, maybe it'll work if I flip this around, put the macro after that other stuff. No, it didn't make any difference. Okay, got UV's there. So it's the color map. Is maybe... So it'd be... Is that MIP info not initialized maybe? Lit input. Okay, I don't see the textile size or the MIP info actually. Okay, this core. Okay, no, that doesn't. I was gonna say this doesn't Oh, here's the... Oh no, I was gonna say it doesn't, well, I thought I didn't define the textures, but here they are. But where, I don't see, where did they define the textile size? Because yeah, it's not here in the C buffer. Okay, so it's in surface input and it's not in a buffer. I guess that kind of makes sense because these are set globally for the texture. Although I guess the textures are set per material. So I just don't know. Does this not? Wait, I'm so confused. Okay, so the base map actually isn't here. So this includes surface input, and surface input has more stuff, and this is not in the material or in the instancing constant buffer. Okay, that's the only time that is ever. Same with the MIP info. So I'm guessing MIP info is set automatically, but maybe I should see. So Unity MIP info. Each of these materials has a property. For every streaming texture it uses, the property is called MIP info and contains the following values. These properties, okay. Example, blah, blah, blah. Okay, so I guess it's just set automatically. Okay, well, let me pull them out of the constant buffer and see if that's the issue. No, that didn't do it. Okay, well, I'm pretty confused here because I definitely initialize everything. You can see, yeah, I initialize everything by setting it to 0 right here. That's the whole point of this thing, but then it's starting to complain about this. Well, what happens if I just remove the macro? Output parameter. Okay, so now it's at line 32. Okay, and this happens after when you call can debug override output color from the lighting function, because it calls this right there. Oh wait, is it the? I know it's still the input data. It's so confusing. Why is it saying that? I don't know. We're gonna have to return to this because yeah, I need to get going. I'm really sorry to kind of leave on a cliffhanger, but yeah, Unity is not being very helpful here with its error, and yeah, it's turning out to be kind of a head scratcher, but we'll figure it out. I really love this rendering debugger, so I definitely want to get it working. But anyway, thanks everybody for coming by. I really appreciate it. I'll put some links in the chat if you enjoyed the stream and you'd like to catch up. Some other are on my other social media. Either way, I'll be live Friday at same time at 2:30 Eastern time, and we'll probably continue with this. Maybe I figured out this bug off screen though. But I hope you all have a great couple days, and I'll see you Friday. Bye bye.